In this video, we will demonstrate the intelligent tutors built for teaching the concepts of loops and recursion in computer programming. Usually, they pose high cognitive overload on the learners. As you can see here, while teaching nested loops to access and modify matrix elements, there are too many moving parts to take care of. It is important that the learners keep track of the variables and understand the flow of the code while it is executing. Same is the case with the concept of recursion. Though evaluating factorial seems a straightforward task, a recursive definition of factorial seems to throw problems. We delve deeper into the issue of cognitive overload based on the concepts taught in the summer school. We figured that the tutors for these two concepts should take the cognitive theory of multimedia learning into account. The key assumptions underlying this theory are limited capacity, that each channel has a limited working memory capacity, as well as active processing, that multimedia learning is an active process of organizing and integrating the content presented. For achieving this, we wanted to limit extraneous processing, which is not required for making sense of the content, and rather focus on essential and generative processing. Thanks to the cognitive tutor authoring tools, which let you build the tutor interfaces, keeping these concepts in mind. We resorted to example tracing tutors by picking code examples that represent the underlying concepts of loops as well as recursion. We applied the cognitive task analysis of think-alouds, where the participants were asked to walk through the code by keeping track of the variables and output at every single line. We made sure that the participants kept talking and identified the potential places where the cognitive overload is occurring. For instance, in the loops problem, participants had difficulties keeping track of the variables and understanding when the inner loop ends. Same is the case with factorial problem, where the variable value of x as well as the recursive call of factorial were the issue. After identifying the issues, we moved over to CTAT authoring tools and then started to build the interface. The CTAT authoring tools editor is very flexible. You can drag and drop the items that you want to include in your tutor and set their attributes as required. Mainly, the hint button is the key for the tutor. So let's see the tutor interface that we built for nested loops. That's the code, and above is the description. And these particular boxes, line number, I, J, as well as the row and column indexing, so they were included based on the think aloud task. Now let's see how this interface looks like for the student. Okay, so this is the interface. Now this interface, you can choose to give the initial state for the student, right? So the code is at line number 1, and all the elements in the matrix are initialized with zeros. So you create the start state in the CTAT tools, you give it a name, and from now on, you demonstrate to CTAT how the correct solution or the correct flow looks like. So each time you add a correct step, the step is sort of reflected in the behavior graph in CTAT. So you could also add the skill that is required to move from one state to the other state. Okay, so in this case, it is basically assigning the variable value of I with a certain value. So I have that skill listed right there. And then the next step is you move to the next line of the code. So you update the line number, and the corresponding skill that you want to update is basically the skill of code flow. So which is what I'm updating right there. Now, once you finish all the correct steps that are required to reach the final state, which is what I have. So I have all the elements in the matrix that are updated based on the code snippet that I've given there. So basically we traced through the example, and that's why this is an example tracing tutor. Now we can take a look at the behavior graph that is generated while we were tracing the example. Okay. Now once the tutor is deployed, the tutor will give you hints whenever required. There is an option to customize these hints as well. And if you enter a wrong input, it's going to mark it in red. And you can also observe the skill meter down there. Okay, so the skill meter is going to be updated each time when you enter an input. This way of step-by-step walkthrough of the code with assistance is going to help the learner understand the underlying concepts. I'm going to pass on to Rebecca, who implemented Factorial Tutor.
Hi everyone, I'm Rebecca. I'm going to show a short demo of the recursion tutor we built. With this tutor, students perform code reading task. Use the given factorial function on the left-hand side. Students are asked to compute factorial 4. Here's the text input box on the right-hand side. Here. While executing the code, students have to update the current line number of code. This is pretty much the same like the one in the nested for loop tutor. Updating the line number reinforces students to actively trace the code. Below, there's a tree diagram. With the exact number of boxes given, it provides scaffolding for students. Moreover, the visual input makes the complicated process much clearer. Students can fill in the boxes step by step. Okay, let's look at the left corner. One of our knowledge components is backtracking. The interesting point we observed in the CTA Think Aloud task was that although the learner completed the tree diagram, the learner still had a little struggle and hesitation filling in the formula here. This is because the learner was not sure whether those values should be ascending or descending. Therefore, we implemented the arrows hint. So after students complete the tree diagram, when they click on the button, the arrows appear. These arrows show the direction of backtracking. With this little hint, a student can understand backtracking more. Now I'm going to show the behavior graph of the recursion tutor. This is just part of the behavior graph. In fact, the recursion tutor only has one solution. However, we try to capture several potential errors. We capture these errors in order to give good feedbacks that provide explanation why it's not correct and how you can approach correct answers. For example, at this state, we give the message, please check again if the conditional statement is true or not. So basically, we provide feedbacks based on what the mistake is.
That's it. We'd like to thank our mentor Jonathan from HCI Institute at Carnegie Mellon and all the instructors at the LearnLab Summer School, as well as the authors of CTAT authoring tools. There's plenty to learn and improve on these tutors.